Alright, so we're going to go through this question right here, in which we write down the equation of the axis of symmetry of the graph. And we know the formula is x is equal to minus b over 2a. We had identified our a, in which we rewrote the f of x, which is equal minus x squared plus 5x plus 3. Our a, the coefficient of x squared is equal to negative 1. The coefficient of b, which is our 5x, is equal to 5. And our c, which is our constant, is equal to 3. So in order to find our x, we say minus b, which is minus 5, divided by 2 times a, which is a negative 1. And so we have a negative 5 divided by 2. When we're dividing by 2, negative signs will be 5 divided by 2, which is equal to 2.5. Additionally, when we are asked to state the maximum value of the function, and because our function is a negative, we know that it will have a frown, right? It will have a maximum value. So the formula is y or k is equal to 4ac minus b squared divided by 4a. We have already found our a and our b and our c, so we say y is equal to 4, our a is equal to negative 1, our c is equal to 3, subtracted from b squared, which is equal to 5, divided by 4a. And so we have 4 times a negative 1, which is a negative 4 times 3, and that will give us a negative 12, and a 5 squared will give us 25. The negative 12 minus 25, that's equal to 37, divided by minus 4, and our answer is equal to a 9.25. Additionally, what this means is, and we're looking at this graph right here, is that for our axis of symmetry, at 2.5, which is our axis of symmetry, so at this line, which is our mirror line, if you were to flip the graph on both sides, it would be symmetric, right? The maximum point that the graph will go or can go is 9.25. As you see right here, so this right point here, which is when we look at the x coordinate, which is 2.5, the y coordinate, which is 9.25, so this is the maximum point of the graph. At this point, we see the graph turning, right? And we see the graph turning downward. So we see the graph rising to where y is 9.25, and at that point the graph turned and went down, right? So that is the coordinates, which is x is 2.5 and y is equal to 9.25. So that are the coordinates of the turning point. Alright, so additionally our question now, it says given the matrix W is equal to 3, 6, negative 2, and 5, we're going to determine a 2 by 2 matrix for L such that when we add a matrix W plus L, it's equal to 0, 0, which is our null set, right? And so because we don't know what L is, we're going to say 3, 6, negative 2 plus L is equal to that, right? So we need to make L the subject. So what we're going to do, we're going to subtract this matrix on both sides. So we'll have 0, 0 minus this matrix. And before we do the subtraction, we see that a negative is being affected by this bracket. What we can do is to affect the negative sign by the bracket. Negative times the 3 will equal negative 3. Negative times the 6 will equal negative 6. And the negative 2 times the negative 2 will be a positive 2. Negative times the 5 will equal a negative 5. And so when we're testing it, we see that for this, which was matrix W, and then we found this to be matrix L, if we added these two, 3 plus a negative 3, that would be equal 0. 6 plus a negative 6, that would be equal 0. A negative 2 plus a 2, that would be equal to 0. And a 5 plus a negative 5, that would be equal 0. So then, this matrix here, if we added these two, it would be equal to our empty set. We're now asked to, the matrix M is defined as 7, 2, P, and negative 1. We're going to determine the values of P for which the matrix is a singular matrix. So we need to first find the determinant of a matrix. And to find the determinant of a matrix, we know that matrix M is equal to AD minus BC. To make a matrix singular, or to test if it's singular, we need to equate that matrix to 0. So we're going to equate, or whatever the value for a matrix is, we're going to equate it to 0 to make it a singular matrix. Alright, so first, in order to test or find our determinant, we say 7 times negative 1 is equal to negative 7. 2 times P is equal to 2P. And so this would be our determinant. Or we can't simplify it any further. In order to test if it's a singular matrix, we need to equate it to 0. And so we say as negative 7, we're going to add 7 on both sides. And when we have a 7 on both sides, it will be 0 plus 7 is equal to 7. Negative 2p is equal to 7. So we're going to divide through by a negative 2. And it will be equal to 7 divided by negative 2. And our p will be equal to a negative 3.5. Alright, for part C, it says A and B are two 2 by 2 matrix such that A is equal to 1, negative 4, 2 and 3, and B is equal to 5, negative 1, 0 and 3. We're going to calculate 2 times A plus B. What we're given here, we're given a scalar multiplication in which we're going to multiply 2 by matrix A. So when we multiply 2 times matrix A, we'll get 2 times 1, 2, 2 times 2, 4, 2 times negative 4, negative 8, 2 times 3, 6. When we add in these two matrices, it will be 2 plus 5 gives us 7, 4 plus a negative 1 gives us 3, negative 8 plus a 0 will remain a negative 8, and a 6 plus a 3 will give us a 9. And that was how we would calculate 2A plus B. A simple 2 marks there, quite easy. Alright, so now we are going to find the matrix, the product of matrix A times B, and we're going to show if they are commutative with A times B, if they're commutative with B times A. We're given matrix A times B. This is our matrix A, which is equal 1 and a 2, negative 4 and a 3, and our matrix B, which is equal 5, negative 1 and a 0 and a 3. To multiply them, we're going to use row by column. We're saying 1 times a 5 plus 2 times a 0. And that will give us the first element in the first row. Then to get the second element in the first row, we say 1 times a negative 1. Then we say 2 times 3. To get this, the second element in the second, or the first element in the second row, we say negative 4 times a 5 plus a 3 times a 0. And when we say negative 4 times a negative 1 plus a 3 times a 3 to get the fourth element in the second row. And our answer will be 5 times 1, 5 plus 2 times 0, 0. So we have 5. Negative 1 times 1, 1. 2 times 3, 6. Negative 1 plus 6 equal a 5. And 4 times 5, negative 20. 3 times a 0, 0. The answer will be equal to negative 20. Negative 4 times a 1, 4. Plus 3 times 3 equal 9. And so that will be equal to 13. In now finding B times A, we put our matrix B in front and our matrix A. And we still do the same cross product, multiplying row by column. 5 times a 1 plus negative 1 times a negative 4. Then to get the second element in the first row, we say 5 times a 2 plus a negative 1 times a 3. To get the second element in the first row, we say 0 times a 1 plus 3 times a negative 4. We say 0 times a 2 plus 3 times a 3. And the answer that we got for this one would be 9, 7, negative 2, and 12. So in testing if they're equal, for matrix A times B, we get 5, 5, negative 20, and 13. And for matrix B times A, we get 9, 7, negative 12, and 9. And realize that these are not equal, hence they are not commutative. So we need to write this statement in which we say A times B is not equal to B times A, hence not commutative. Okay, they did ask us to give a statement or show that it's not commutative. And for this question now, we're going to find the inverse of matrix A. So we have matrix A is equal 1, 2, negative 4, and 3. To find the inverse first, we need to find the determinant. Then we find the adjoint. Then we multiply 1 over the determinant by the adjoint. So the determinant of this matrix is equal to 11 because we're saying 3 times 1, 3. And negative 4 times a negative 2 equal negative 8. And we should have a subtraction. These two negative signs, we're going to add them, and it will be 11. So two negative signs are going to affect and become a positive sign. Alright, to find our adjoint, we have a 1 and a 3 and a negative 4 and a 2. We're going to interchange these two terms on this leading diagonal, and I want to change the sign of these two terms on this other diagonal. We're going to change the sign by multiplying it by a negative 1. We're going to interchange these two terms. The position of them will be a 3 and a 1. Change the sign of the 2, multiply by negative 1, be a negative 2. Multiply the negative 4 by negative 1, it will be a positive 4. Multiplying our 1 over determinant by the adjoint we get 1 over 13 times 3, we get 3 over 11. And 1 over 11 times negative 2, we get negative 2 over 11. And 1 over 11 times 4, we get 4 over 11. And 1 over 11 times 1, we get 1 over 11. And this right here is our inverse. All right, additionally now, we are given this question. It says, given that 5, negative 1, 0, and 3, and x and y, we're going to find the values of x and y when we say this matrix. So it will be in the form A, x equal B. Yes. And that's the form that it is in. Ax equal B. In order to do this, we can still apply the inverse and find it. But if we want to find A, we know we would transpose our x and we say B minus A. So these value for which is our B, we're going to subtract them from this value right here. In order to remove the A, it will be an A inverse, right? So that's why we would subtract it. And in order to remove the A to find the values of x and y, subtracting the A on both sides, carrying it over right here, it would be an A inverse. All right, so that's why we need to find the inverse of the A. Then we subtract it or multiply it by whatever B is. All right, so we found our determinant. 5 times 3, 15. 0 times negative 1, 0. So 15 minus 0 is equal to 15, and 1 over determinant is equal to 1 over 15. The adjoint now, we add a 5 and a 3 and a 0 and a 1. We interchange the 5 and a 3 to be 3 and 5. We times the negative 1 by a negative 1, that will be a 1. Times our 0 by a negative 1, that is equal to 0. Then we multiply 1 over the determinant by our adjoint. It would be 1 over 15 times 3. That is equal to 1 over 5. 1 over 15 times 1, that's equal to 1 over 15. 1 over 15 times 0, that is equal to 0. 1 over 15 times 5, that is equal to 1 over 3. Alright, so now we're going to write it in this form, in which we have the ax times the inverse is equal to b. Alright? And so what we need to do now is need to get the inverse of A over to the side where B is. So we do that now and we multiply the inverse by our matrix B. What we would get is the 1 over the determinant, the 1 over 15 times 30 and 15. Right? So basically what this is 9 over 3. Right. So it would allow us to get this answer right here, in which this is a 2 by 2 multiplied by 2 by 1. And we know what would get is a 2 by 1. Right? So this is what the matrix I would get, a 2 by 1. 2 row by 1 column. Right? And so what we're going to do now is 1 over 15 times 30 will give us a 2. And 1 over 15 times 15 will give us a 1. So x is equal to 2 and our y is equal to 1. And that is the value of x and the value of y.